Hello, in this video we're going to talk about transformations, and we're going to talk about different types of transformations. The first one are translations and horizontal and vertical translations. So these are functions that are operations that move the graph left or right or up or down. If the number occurs within the function, so if the function is f of x plus c, and so if we add a number here, then we are going to shift to the left. And if it occurs within the function it's negative, then we're going to shift to the right. And this is a little bit counterintuitive. So if it is a horizontal translation, the thing to keep in mind is you have to change the sign or do the opposite of the sign. So positive shifts left and negative shifts right. Now, if you contrast that with the vertical translation, there's a couple differences. One, the number will occur out after the input or the function has been applied. So it's outside of the parenthesis, it's outside of the function, which we'll see in examples. It doesn't have to be behind it. It could be in front of it. So it could be like c plus f of x. That's still a vertical translation. But if it's positive value, then it's going to shift up. And if it's negative, it's going to shift down. And so this, we're going to keep this sign, or what you see is what you get when it comes to a vertical translation. Okay, another way to transform a function is by the vertical stretch or shrink, and that will occur, or sometimes compression is what you could say, vertical stretch or compression. And that will occur when a number is multiplied by the function. Now we want to ignore the sign. So ignore like if it's negative c or positive c. We'll talk about that with the reflection. But so we'll say the absolute value. If the absolute value of c is greater than 1, then it is a vertical stretch. This means the function will get skinnier. If you take it and you stretch it out, it'll get skinnier. It'll pull those things together. If you think about like stretching a rubber band, the rubber band gets closer together. If the absolute value of c is in between 0 and 1, then it is a vertical compression. It'll get wider, or if it's like think about an absolute value curve, the V-shaped, it'll get wider apart, or the V will get fatter, like flattening a rubber band. The rubber band gets wider. Well, it's kind of hard to do. Okay, but the important thing is to don't think about fractions. So a lot of times a shortcut will be like, well, if it's a fraction, it's a vertical compression. If it's not a fraction, it's a vertical stretch. But sometimes fractions can be bigger than 1. So just make sure you think of, if it's bigger than 1, it's a vertical stretch. If it's less than 1, it's a vertical compression. And just ignore the sign, because if there's a negative out front, then that will have a reflection. So if it's negative in front, it reflects over the x-axis. And if there's a negative before the function's applied, like inside the parentheses or inside the square root, inside the absolute value, then it's going to reflect over the y-axis. So this is another way to think about this. This is like an up-down reflection or vertical reflection. And this is a left-right reflection. Okay, so those are the definitions you need. Now the best thing to do is probably just look at some examples. So let's dive into those. And so we're going to start with this, what's called the parent function here, and sketch that. And we'll just get a couple points here. So we know that it's that swimmer's arm looking graph. 0, 0 is on there, 1, 0, and then the square root of 4, 1, 2, 3, 4 is 2. And so we'll sketch this graph here, and we'll label it f of x. So that is what a square root curve looks like. And really with a sketch, like if you only have this first point, this initial point or terminal point, then that's fine. And then just sketch in what the curve looks like. And then with this function, you see this +3. So you say, well, what is that +3 going to do? How's it going to transform the graph? That's going to move the graph left 3. So we take every point, 1, 2, 3, and move it left 3. And we'll go ahead and keep the other points kind of specific and shift those 2. Although with the sketch, if you really just have one point, that's fine. And so this is g of x. Okay, try that. Pause the video. Try the next example on your own. And then maybe the most important thing is that you can describe the graph. So here we have x minus 4 plus 1. So inside the function is minus 4. That's going to shift it lower. And then it's outside of the absolute value bars. So that's going to shift it, or the 1 is outside the absolute value bars. That's going to shift it up or down. And in this case, it is up 1. Okay, my computer almost crashed on me. We'll see how that edits out. But here it's right 4 and then up 1 because of this one here. And so this graph, this absolute value function looks like a V that starts at the origin 0, 0. But we're going to take that V and move it right 4, 1, 2, 3, 4, and up 1. So here's my new vertex. And then it just continues with the slope of 1 in both directions. Try to get that as good as possible. And so there is your graph. Okay, and then a few more examples here. So pause the video and try these, and we'll go through them kind of quickly. One thing to notice is these are all parabolas. And then we're going to sketch them on each graph. So let's see, I think we can use different colors for each one. So this is going to go right 2. Remember, it does the opposite of the sign, and then up 1. And y equals x squared is just a parabola. It's that U-shaped curve. So if I move it right 2 and up 1, then it will just look something like this. And we'll just do the 3 points and sketch. Okay, then this is gonna, this negative here is gonna reflect over, or some of them say in, the x-axis. It's gonna reflect it up and down. And then the 3 is gonna take it down 3. And we'll use blue for this. So I'm gonna go down 3, 1, 2, 3. And instead of opening up, that negative is reflecting it over. So it's gonna open down. And we'll just take those first 2 points and then sketch the U, and that'll be enough. And then on the last one, the 3 inside is going to go right, left 3. And then down 4. And then the 2, the down 4 is here. And make sure that we are changing the sign, or doing kind of the opposite of the sign here. And then here we are keeping the sign. And the 2 is going to be a vertical stretch by a factor of 2. And it's okay if you say like vertical stretch by 2. If you want to abbreviate that somehow, that's okay too. But let's do this. So we go left 3, 1, 2, 3, and down 1, 2, 3, 4. Counted correctly. And there's my vertex. And then instead of going up 1, I'm going to multiply it by 2. Everything's going to be stretched out by 2. And so you'll notice that this parabola looks skinnier than the other ones. And you could add more points if you wanted to. If you wanted to plug in like -1 to see what you get there, that might be a good idea. Another good idea to kind of understand this stuff is to open Desmos and graph these in Desmos and start with this, like graph them all at once, or just like start with this function. Start with y equals x squared. Graph that in and like pay attention to what happens when you add 1 to the end, or if you add parentheses in the -2, and kind of explore what's happening with the graphs and compare them. That can be a very useful thing to do to really try to understand what's happening rather than just memorize things. But there is some memorization. So memorize the transformations, what the rules are, and you should be good to go. But good luck with this, and reach out if you have questions. Hope that works.